Okay, so before we start this next example, I just looked this up, and the Chinese currency is pronounced yuan, or I guess A-A-N, yuan, the yuan. So we converted between US dollars and yuan. Problem number 8 is going to use this picture. We're not to the map yet. Forensic scientists often examine scaled up crime scene photos to search for evidence that might be hard to identify in a regular size. Studying bite marks on a photo of a victim's leg at 500% magnification, a technician has measured the distance between two punctures from the site to be 165 millimeters. What is the actual distance between the puncture? The actual distance between the puncture. So, the ratio of the photo size to the actual size is 5 to 1. Photo to actual. 500%. Actual would be 100%. 500% would be magnified, made larger, and that's where we get the 5 to 1. So, remember that the photo is in the numerator, and the actual size in real life, the bite, would be in the denominator. All right, so if the ratio is 5 to 1, we have 5 in the photo and 1 in the actual. And on our photo, the bite is 165 millimeters. And we want to know how large is the actual bite. These are going to be equal. I have just set up this proportion. Everything in a photo is 5 times bigger than it is in actual life. So on this side of the equal sign, this bite in the photo is 165 millimeters. What is the bite in actual size? And we love it when there are two fractions with an equal sign in the middle, because that means these two multiplied together, 5 times x, will equal these two multiplied together, which is 165 millimeters. And if we want to get x by itself, divide both sides by 5. And we're going to get x is going to equal 33 millimeters. 1/5, or something that's magnified 5 times, would get 165. That number would be 33. The actual bite size in real life would be 33 millimeters. All right, and then for these last questions, we're going to be looking at this map. The questions are on the next page, but let's just at least get an idea of what's going on the map. Here, in real life, we had a bite, which was 35 millimeters, and we magnified it 500 times. This is the other way. This would be the other way of looking at a problem, and that is a map is a scaled down version from real life. The map is smaller than real life. So here's a map of the east side of Dubuque, Iowa, the driving path from a casino on the river. Here's the river. Here's the casino, the entranceway into the casino, and then this service road off of the expressway, Route 20. Then you take Route 20, you go over the river, and then you exit over to this golf course. This is showing the distance from the casino to a golf course. According to the Maps app on my phone, the driving distance is 3 miles. So this in real life is 3 miles. We're most interested in the graphic at the bottom left, which indicates that 1 inch on the map corresponds to 2,000 feet in real life. And we have that, this is right here. This is an inch. 1 inch on the map is 2,000 feet in real life. 1 inch is 2,000 feet. This would be on the map. Map is in the numerator. Real life is in the denominator. 1 inch to 2,000 feet, map to real life. All right, so let's remember that as we go to the next page for the actual problems. Write the ratio that compares the size on the map to the size in real life. Okay, so map in the numerator, real life in the denominator. 1 inch is equal to 2,000 feet. That's our ratio. Number 10, points A and B on the map are 4.06 inches apart. How far apart are the casino and the golf course in miles? All right, well, so we're going to get feet, and then we're going to have to change feet to miles, and they tell us to use proportions. So map is in the numerator, real life is in the denominator. 1 inch is to 2,000 feet. Now here, let's look at, this would be for everything on the map. Let's look at our route. Our route is 4.06 inches. And we want to find this value. So we're going to cross multiply. These two multiplied together will equal these two multiplied together. So we've got 2,000 times 4.06, that would be feet times inches, is going to equal 1x. And this would be feet in our denominator, units in the denominator. All right, so when you multiply 2,000 by 4.06, you're going to get 8.120 feet. 8,120 feet. All right, but the question didn't ask how many feet, it asked how many miles. So 8,120 feet, we want to multiply by a fraction that has feet in the denominator and miles in the numerator. This would equal 1 so that our feet can cancel, and there are 5,280 feet in a mile. Feet cancel, and when you multiply across, what is 8120 divided by 5280? That's 1.54 miles apart. So this is a ratio. Two ratios with an equal sign in the middle are called a proportion. And then we just had to change our answer, convert our answer to miles because our proportion was in feet. So write an equation of variation that relates the distance on the map, m, to the distance in real life, r. Then use the information you know to solve for a constant of variation. All right, so the distance on the map is going to equal, this is a direct variation. The bigger the distance on the map, the bigger the distance in real life. This is a direct variation. So we are going to multiply our constant by the real life the real life distance. So 1 inch on the map is equal to K times 2,000 feet in real life. We were told 1 inch on the map is equal to 2,000 feet in real life. So what is K? Divide both sides by 2,000. So my constant of variation is the fraction 1 over 2,000. So let me rewrite our equation now. The distance on the map is going to be 1 over 2,000, the distance in real life in feet. That's your answer. If we looked at a satellite photo of at the same scale as this map, do you think we could see any boats on the river? Okay, so I don't know, how big is a boat? Is it a 20-foot boat? A 20-foot boat? Let's see. How big would that be on the map? And of course there are smaller boats than that. I guess there are bigger boats than that too. But in feet, 20 feet, M is going to be 20 over 2,000. So that's 1/100th of an inch. 1/100th of an inch. Do you think we'd actually be able to see that 1/100th of an inch on the map? I would say probably not, but this is an opinion question. If you think that that small amount would show up on that scale. So let's say a 50-foot boat. Let's say a 50-foot boat was out on the river. The typical recreational motorboat is from 18 to 24 feet range. So use our variation to find out how big that boat would be in the satellite. Well, that's going to be 1 over 2,000 times 50, which is going to be 50 over 2,000. And so that's going to be 0.025. This was 0.01, 1/100th of an inch. This is 0.025. So more than twice this of this size, but still that's pretty small of an inch. You know, if that's a typical inch, 1/100th of that would be, I don't know, like right there. Would we be able to see something that's 0.025 of this? Again, that I'm going to say no, but that is an opinion question.